Today, we're diving into something huge, a geological process so vast it literally reshapes the entire face of our planet over and over again. We're talking about Earth's grand cycle. It all kicks off with a really simple question, one you probably ask yourself as a kid staring at a world map. Have you ever noticed how the coastlines of, say, Africa and South America look like they could just snap together, like two puzzle pieces? Is that just a weird coincidence? Well, the simple answer, nope. It is absolutely not a coincidence. They were once connected. But here's the really mind-blowing part. Their movement isn't random at all. They're actually on a path to come back together again. So this incredible repeating process actually has a name. It's called the supercontinental cycle. And the idea is pretty simple, but huge in scale. Over hundreds of millions of years, the continents smash together to form one giant landmass. Then they break apart and drift away, only to eventually find their way back to each other. It's basically our planet constantly rearranging its own furniture. Okay, so to really get our heads around this cycle, we have to start with a pretty fundamental truth about our world. I mean, the ground beneath our feet feels solid, right? But on a geological timescale, it's anything but static. Our entire planet is in constant dynamic motion. And a really great way to picture this is to go back to that puzzle idea. Don't think of Earth's surface as a solid shell. Think of it as a very, very slow-moving puzzle. The continents are the pieces, and they are always shifting, bumping into each other, and drifting apart. All right, so let's dive into the first half of the cycle. How does this even work? How do all these scattered continents manage to come together to form one single giant landmass? Well, this is the story of the Great Collision. Okay, so picture it. You've got continents scattered all over the globe, separated by massive oceans. But deep under those oceans, something is happening. The heavier oceanic plates are constantly sinking down beneath the lighter continental plates. That process is called subduction. And as those plates sink, they create this really powerful slab pull force. It's like they're dragging the continents along behind them, like giant anchors, slowly but surely closing the distance. And the finale of this whole process? It's absolutely spectacular. When these continents finally crash into each other, their crust is too buoyant, too light to sink. So what happens? It has nowhere to go but up. It crumples and buckles, forming massive, massive mountain ranges. This whole mountain-building process, it's called orogeny, is what slows everything down, locks the continents together, and boom, you've got yourself a supercontinent, just like the famous Pangaea. But here's the thing. No supercontinent gets to stick around forever. In fact, the very thing that creates it, its massive size, is what also leads to its own destruction. So let's get into the second act of this incredible story, the Great Breakup. So you're probably wondering, how on earth does a landmass that big just tear itself apart? Well, a supercontinent is so huge, it basically acts like a giant thermal blanket for the planet. It traps an incredible amount of heat rising up from the Earth's mantle. All that trapped heat just builds, and it starts to weaken the planet's rocky outer shell, the lithosphere from underneath. Eventually, all that pressure gets to be too much. Magma punches right through, cracking the supercontinent into pieces. New oceans start to form in those cracks, and the continents begin to drift apart once again, starting the whole cycle over. Okay, I know what you might be thinking. This is an awesome story, but it sounds a little bit like science fiction, right? So the big question is, how do we actually know any of this is real? Well, let's take a look at the clues the planet itself has left for us. Think of scientists as detectives, but for deep time. They've pieced this incredible story together from all sorts of clues. I mean, you've got the obvious one, the puzzle piece fit we talked about. But it goes so much deeper. We find identical fossils of plants and animals on coastlines that are now thousands of miles apart. We find ancient mountain ranges that just stop at the edge of one continent and then pick up again perfectly on another. We can even look at the magnetic signature locked inside ancient rocks to figure out exactly where on the planet they were when they formed. It's amazing stuff. And all this evidence points to one incredible conclusion. Pangaea, the one supercontinent we all learn about in school, yeah, it wasn't the first, not by a long shot. This cycle has happened over and over again. Geologists have found evidence for earlier supercontinents, like one called Pangaea around 600 million years ago, and another called Rodinia, which existed way back, over 1 billion years ago. Okay, so at this point, we know what happens and we know how we know it happens. But now we get to what I think is the coolest part, the deep, elegant, competing forces that are actually driving this whole planetary engine. And really, it all boils down to this constant planetary scale tug of war. On one side of the rope, you have the massive gravitational pull from those sinking oceanic plates, just relentlessly yanking the continents closer together. And on the other side, you've got the incredible force of the Earth's internal heat, building and building under a supercontinent until it has enough power to literally rip it apart. This cosmic dance between gravity pulling in and heat pushing out, that is what powers the whole show. You know, when you really stop and think about all this, it leads to a pretty profound realization. That map of the world we're so familiar with, it's just a single frame in a movie that's been playing for billions of years. Our continents aren't permanent at all. They're just wanderers floating on a planetary sea of magma. And it's this constant rearrangement that makes our planet's story so compelling. This cycle is responsible for long-term climate change. It shapes the very course of evolution itself. So I'll just leave you with this final thought. Over timescales we can barely even imagine, our world is in a constant state of rebirth, slowly, deliberately rearranging itself, again and again.